The heat wave finally breaks. People step outside, feel the cooler air, and assume the danger has passed. Doctors, meteorologists, and emergency officials all say the same thing about that exact moment, and they have been saying it more urgently every single year. It is not the end of the danger. It is the beginning of a different one, and scientists are genuinely worried people are not taking it seriously. Europe just lived through this pattern in real time. A powerful heat dome locked over Western Europe this summer, trapping hot air pulled straight up from North Africa. Spain, Portugal, and France sat at the center of it with temperatures. The same dome expanded outward, stretching across the UK, Ireland, the Benelux countries, Western Germany, Northern Italy, the Alps, and the Balkans within just a few days. National weather services from Berlin to Prague issued red alerts for extreme fire danger as low humidity and erratic winds turned already dry vegetation into fuel. This was not a mild summer warm spell. Meteorologists described it as historic, and the numbers backed that up. June and all-time high temperature records fell across the UK, France, the Benelux region, Germany, and Switzerland. Transport systems buckled under the heat. Rail lines slowed, roads softened. In France, average daily temperatures sat near 30 degrees, spiking above 44 in at least one town, and researchers estimate the heat contributed to roughly 1,000 excess deaths in that country alone during the peak of the event. Then, just like every heat dome eventually does, this one began to collapse. And that collapse is exactly where scientists say the real concern begins. Notice what just happened there. The heat itself made every headline for days on end. The collapse that followed barely got mentioned in comparison, despite injuring well over 100 people in a matter of minutes in some towns. That imbalance in attention is exactly the pattern scientists are trying to correct. A heat dome does not simply fade away once it breaks down. It releases. All the heat and moisture that built up underneath it for days has nowhere left to go once cooler air finally forces its way in. The result is not a gentle return to normal weather. It is violent, fast-developing severe weather, arriving almost exactly when people have let their guard down the most. Across Central Europe, as the blocking high finally gave way, forecasters warned of a dramatic shift. Severe thunderstorms, large hail, damaging wind gusts, and even isolated tornadoes became real possibilities. Across Switzerland, Austria, and northern Italy, before spreading further into Slovenia and Croatia, rainfall totals in some mountainous areas were expected to reach 100 to 200 millimeters in a matter of hours, concentrated almost entirely around the moment the heat dome finally broke apart. Northern Italy in particular has a well-documented history with this exact pattern. The region sits in one of the most hail-prone parts of the entire continent, and past heatwave collapses there have produced genuinely dangerous results. In one memorable stretch of destructive storms, supercell thunderstorms following a prolonged heatwave produced hailstones of record-breaking size, injuring more than 130 people across multiple towns. In one town near Milan, a single hailstorm following a heat wave injured over 100 people in a matter of minutes. These are not freak one-off events. They are a recurring feature of how heat waves in this region tend to end. The United Kingdom experienced its own version of this whiplash pattern during the same stretch of extreme weather. After weeks of exceptional heat and record-breaking dryness, the eventual breakdown of high pressure brought sudden storms and a sharp drop in temperature within days. Yellow thunderstorm warnings followed almost immediately after some of the driest conditions the country had recorded in decades, catching water companies and emergency planners in the middle of an already difficult balancing act between drought management and sudden flood risk. That kind of rapid swing from drought concerns to flash flood warnings in the same week illustrates just how quickly the atmosphere can flip once a prolonged heat pattern finally gives way. So, why does the collapse turn violent instead of simply cooling things down peacefully? The mechanics come down to basic atmospheric physics. A heat dome is a stalled area of high pressure that traps warm, increasingly unstable air underneath it for days at a time. While it sits in place, the atmosphere is essentially loading up, with energy and moisture, like water, building up behind a dam. On the other side of that high pressure, cooler air keeps pushing in from the north or from the Atlantic, but it cannot break through until the jet stream shifts enough to force a change. When that shift finally happens, the two air masses do not gently blend together. They collide, often producing the exact ingredients needed for severe thunderstorms, large hail, and destructive straight-line winds. Scientists studying this pattern point to a specific detail that makes it especially dangerous. Heat itself does not prevent hail from forming, and in some cases it actually helps create the conditions for it. The intense heat that builds during a dome event, combined with the moisture trapped underneath it, can produce exactly the kind of atmospheric instability that fuels powerful supercell thunderstorms once that heat finally gets displaced by cooler air. In other words, the more extreme the heat wave beforehand, the more energy is available to fuel violent storms once it finally breaks. Pinpointing exactly when a collapse will happen remains one of the harder challenges in modern forecasting. Weather models can usually identify a general window, sometimes several days out, where a heat dome is likely to break down. But the precise timing tends to shift right up until the moment it actually occurs, since it depends on exactly how and when the jet stream finally punches through the blocking pattern. That uncertainty is part of why meteorologists issue warnings well ahead of time, even when the exact hour remains unclear, hoping to give people enough lead time to adjust their plans before conditions shift. This pattern is also becoming more frequent, not less. Back in 2022, a series of heat waves swept across nearly every country in Europe between June and September, killing an estimated 20,000 people according to official figures, with some researchers placing the real toll closer to 70,000 once indirect heat-related deaths are included. That summer caused roughly $40 billion in damage and triggered thousands of wildfires across the continent. Health experts have since warned that Europe, the fastest warming continent on the planet, needs to start treating extreme heat with the same seriousness as a seasonal flu outbreak, planning ahead for it every single year rather than reacting to each event as a surprise. That same forward planning, experts argue, needs to extend to the storms that follow, rather than treating them as an unrelated afterthought once the heat itself has passed. There is also a financial dimension to this pattern that rarely makes headlines. Infrastructure across Europe takes a beating on both ends of the cycle. Roads soften and rail lines slow under extreme heat. Power grids strain under record air conditioning. Demand. Then, almost immediately afterward, storms arrive and knock out power lines, flood transit systems, and damage property that was already stressed by weeks of drought and heat. Insurance claims tied to storm damage tend to spike heavily in the days following a major heat dome collapse, layering a second wave of disruption on top of a region that had barely finished recovering from the first. What makes the collapse phase so easy to underestimate is simple human psychology. People spend days bracing for extreme heat. They check forecasts obsessively, stay indoors during peak hours, and stock up on water. The moment temperatures start dropping, that vigilance disappears almost instantly. Attention shifts elsewhere, right at the point when meteorologists say the atmosphere is arguably most unstable and most capable of producing sudden, severe weather. Doctors add an important detail to this warning that rarely gets discussed. A body that has spent days under extreme heat. Stress does not fully recover the moment the temperature drops. Dehydration and general exhaustion can linger well beyond the point. When the heat wave technically ends, that means the same vulnerable groups who struggled most during the heat, older adults, young children, and anyone with existing health conditions, are often still weakened exactly when storms, flash flooding, or power outages hit during the collapse phase that follows. There's also a longer-term trend feeding into all of this. Heat domes are lasting longer than they used to, thanks to a pattern scientists call atmospheric blocking, where the normal west to east flow of weather systems grinds to a near standstill. Researchers increasingly link the growing frequency of these blocked patterns to faster warming in the Arctic, which shrinks the temperature difference between the poles and the equator. That difference is part of what drives the jet stream in the first place. As it weakens, high-pressure ridges get stuck in place for longer, allowing more heat and moisture to build up before the eventual, more violent release. So what should people across Europe or anywhere else facing this pattern actually watch for once a heat wave finally starts to ease? Meteorologists point to a few reliable early signs. A sudden shift in wind direction is often one of the first indicators that a collapse is approaching. A rapid buildup of tall, dark clouds after days of relentlessly clear skies is another clear signal. Rising humidity, even as temperatures begin falling, can mean the atmosphere is loading up with moisture ahead of a storm outbreak rather than simply settling down. None of these signs require special training to notice. They just require people to keep paying attention instead of assuming the worst has already passed. Officials also recommend a few practical habits specifically during this transition window, ones that are simple to follow but easy to forget once the heat finally starts to ease. Avoid sheltering under isolated trees during a sudden storm, since lightning and falling branches pose a real risk. Keep devices charged in case of power outages, which frequently spike as storms bring down power. Lines already stressed by weeks of heavy air conditioning demand. And treat the first sound of thunder as your signal to move indoors immediately, since these storms often develop and intensify far faster than typical seasonal rain. The bigger picture here is uncomfortable, but scientists say it needs to be said clearly. A heat wave ending is not the same thing as the danger ending. In many of the most severe cases documented across Europe in recent years, the storms that followed the heat caused injuries, damage, and disruption that rivaled or exceeded what the heat itself produced. Yet these collapse events consistently receive far less attention and far less preparation, largely because people instinctively associate cooler air with safety. Before you go, if this is the kind of pattern you want to understand before it shows up in your own forecast, make sure you like this video and subscribe. because we track these transitions as they unfold across different regions. The next time a heat wave near you finally starts to break, do not relax the moment the temperature drops. Scientists keep repeating this warning because the data keeps proving them right, again and again, summer after summer. Watch how your local forecast describes the transition, not just the falling temperature. Words like severe weather warning, large hail, or flash flood risk, appearing right alongside news that relief is finally on the way, are not routine details to skim past. They are the clearest signal available that the danger from this event has not actually ended. It has simply changed shape, and for many people it arrives faster and less predictably than the heat ever did.